Very good. So now we are moving into our main story of today. AMD got the jump on Intel in the battle for the fourth generation server of CPUs, announcing the so-called Genoa line at SuperComputing 22. AMD's new CPU line is a massive upgrade with more cores, accelerator instructions, and CXL. And it comes ahead of Intel's delayed Sapphire Rapids Xeon announcement, which is widely expected early next year. So let's take a closer look at the AMD Genoa CPU line.
Yeah, absolutely. And this was a very, very important and exciting announcement because, of course, in the data center, although ARM is rapidly growing and getting a lot of attention, it really is still a two-horse race. And unfortunately, one of those horses has been stumbling a little bit recently, and that's Intel. They have tried to push forward their server architecture, Ice Lake and now Sapphire Rapids, which everyone expects is coming next year. These things have been a bit delayed, and a lot of that delay has to do with Intel's tight coupling of processor design and manufacturing. And frankly, there's a lot of steps along the way that those things can get out of sync, and then everybody's got to wait. So that's what we're sort of looking at here. Essentially, Sapphire Rapids was supposed to be out first. It was supposed to be wowing us for a while, and then AMD was going to play catch up. And instead, AMD's here first. And in fact, to the extent, as we'll talk about here later, AMD actually is delivering CXL before Intel in their Sapphire Rapids Xeons. So it's pretty remarkable what's happened here in terms of the turnaround. And the processors themselves look really, really great. So just to be clear, the first Epyc here is the Genoa 9004s. We will see more different processor lines. So everybody expects that we'll see a Genoa X. They're talking about which has 3D memory, Bergamo, which I guess would be a bigger data center, and Sienna, which is more for dedicated appliance. At least that's my understanding. I haven't actually been briefed on those things. I'm just reading the trade press like everybody. So everybody expects that we'll be seeing these next year. But for now, we've got sort of the mainstream, the Genoa server CPUs, and they're really, really impressive. We're talking about 96 cores. One of the biggest things for me is 12 channels of DDR5 memory. Also, another big announcement here is that they've implemented Intel's AMD AVX 512 accelerator instructions. We'll see how well that works. I can't wait to see benchmarks on that because they implemented it quite differently from how Intel would. And of course, I've got to say, as host of Utilizing CXL, that the big news for me is that it's got 64 lanes of PCIe 5 that can be used for CXL connectivity. So those are the big announcements in my mind. Max, what do you see in this launch?
Well, besides the fact that AMD is basing all of its CPU architectures on Italian city names, which kind of I love, but it also kind of makes me trouble and lose my focus when I'm listening to that. I think that you highlighted perhaps one of the most important points there in those architectures. Not looking at what Intel has done or not done. The fact that CXL is available in those architectures is, at least in my opinion, is going to be maybe foundational or perhaps even transformational in, let's say, AMD's growth in the data center, perhaps in terms of adoption. It may not be for commonplace workloads. You may not need to deal with CXL for common general purpose workloads. But as soon as you're looking into high performance data processing, HPC, and so on, where you need to have the performance, where you need to implement, I don't know, I'm just thinking about some architectures which leverage, for example, persistent memory. The fact that you have that they have included that is really important, especially because it's in effect it is becoming an open platform compared to what we have on the other side of the pond, right? So that's where I see value there. Is there support, I think, for PCI Express 5, CXL. So to me, that's the big news there in the CPU architecture. Maybe one downside, and I think we were talking about that before as well, is these are really very power hungry. So that's maybe the only downside I see there. On the other hand, these are maybe CPUs that are really focused at those high performance workloads. So you're probably not going to see the power efficiency there.
So Yeah, let's follow on that point, Max, because it's really important. I mean, we're talking about servers, CPUs that have a brand new socket, a huge power budget. I mean, we're talking about kilowatt servers potentially here if we're talking about a dual socket configuration, and that's just for the CPU. We just wrote a white paper, just published it actually this week over on Gestalt IT, digital infrastructure at data center scale. Now, admittedly, that white paper was sponsored by Intel, but it was conducted by folks like me and Max, not literally, but metaphorically. And we researched the entire market and what are the decision points that go into building servers and server architectures. And for me, the fundamental thing that I've uncovered here in terms of data center and cloud servers is this idea of balance, that you want to make sure that you're balancing all the various factors that go into building a server and not just optimizing for the big wow numbers. I mean, Bergamo, we're looking at 128 core processor coming out next year, theoretically. Wow, that would be amazing. What are you going to do with 128 cores? Now, if you're a cloud service provider, maybe you're selling virtual private servers or something, that might be useful. But if you can only have 3 terabytes of RAM, I know, only 3 terabytes, or 6 terabytes maybe, then is that really going to be a useful thing? Because you have to balance memory, CPU, I/O, all these other aspects of the system, not to mention power and cooling and cost. And what we found in our research, at least into the third generation servers, was that the Intel value proposition was still really strong, even though they didn't have as many raw cores, because they had this balance. You could basically develop a server that would have the right mix of CPU, memory, I/O, accelerators, and cost, and deliver something on a scale that you need. So one of the keys to that solution for Intel was Optane persistent memory, which of course is falling to the wayside now. And now I think we're going to look for CXL as a way to kind of add another tier of memory to kind of close that gap, make sure the system has enough capacity of memory, maybe not performance, but capacity memory, in order to meet the needs of these incredible numbers of CPU cores that we're seeing. Another thing, as you mentioned, is PCIe 5, which of course is faster than 4 or faster than 3. And they have more channels. That really helps as well to bring enough I/O in to feed all those cores, et cetera, et cetera, et cetera. Now, a final consideration that I want to bring up here, though, and this is another thing that we came up with in our white paper, is that Intel also offers chips for different purposes. So they have the Xeon D, they have you know all the way multi-core or multi-socket chips all the way up to 8 sockets, for example. So kind of whatever you're looking for, there was a solution for you. AMD is really trying to challenge that by introducing multiple lines of Epyc processors that would fit into those various niches. And that's really important because previously AMD really didn't have a great competition all across the board. Now there looks like they're going to. Now, of course, this announcement is only the mainstream processors, but we do expect that they'll be announcing a whole line of processors for various purposes in the future. But there's one more factor to consider, and that's manufacturing. Essentially, what I'm hearing from actual data center architects and the folks that are actually building and deploying servers in the cloud is that another thing that's holding them back from ordering AMD is literally the availability of processors and components, supporting components, motherboards, and so on, because of the global supply chain shortage and because AMD doesn't control their own supply chain. It's dependent on TSMC and so on to actually construct these processors for them. And that's been a big challenge. And I think that that's going to continue to be a big challenge. So no matter how excited we are to say 96 cores and PCIe 5 and CXL, and no matter how great this product is, we have to temper it a little bit in terms of practical applications, power and cooling, availability, availability of complete solutions, et cetera, et cetera. There's a lot more that goes into a processor or a server decision than just the processor.
Absolutely, and maybe if I can throw in a last couple of comments. One of the first aspects is efficiency, sustainability. So you get those massive systems. You need to think about if it's a kilowatt, then you need to supply more electricity to your system. Of course, probably there's going to be more heating, more dissipation, more cooling needed. So I think it's kind of there's something that you need to factor in if you decide to go for such an architecture. I don't want to get too much into the details, but we spoke about that at Storage Field Day 24 last week, if I'm not mistaken, or 2 weeks ago. The other aspect, I mean, it's more a kind of a thought or consideration. There seems to be a kind of a runaway kind of trend to build more massive CPUs with more cores, more cache, and so on. And so, to me, it makes me think about what are we going to achieve there. Are we trying to get back to the mainframe era? Do we want to build massive CPUs that are going to be installed at hyperscalers or in large data centers? Are we going to get back to partitioning those and assigning slices of this and that? Maybe that's also what's going to happen with CXL composable infrastructure and so on. That's, I don't know if it's where it's headed at, but it kind of rings a bell a bit on my side.
Yeah, that's actually really, really insightful, Max, because one of the things that CXL is promising and composability generally is promising is that we would be able to sort of mix and match and build the right server for whatever need we will, using this kind of composable hardware and more flexible hardware. We may be living in peak processor right now. This may be the biggest, baddest CPU we will ever see. Because if CXL takes off and if composability takes off, it will really change the balance of what we're looking for in a socket. Like, how many cores do we really want in a socket? If servers look different, if they're composable, if you can have like I don't know, a rack of memory, a rack of processors, a rack of accelerators, and so on, and you can kind of mix and match as needed. Suddenly, this whole like fight to like focus everything into one socket, it really changes. So I would say, from a nerd perspective, this is an amazing launch. It's an amazing product, and I'm really excited to have 128 or 96 now, but 128 soon x86 server processors in a single socket. Ooh, that's cool. But we may never live in this world again.